Hello everyone, welcome to this lesson. In this video, we're tackling Maclaurin series. In an example, you are told to find the Maclaurin series for the function f of x to be equal to sin of x. Now, the first derivative of sin of x is cos of x. The second derivative, the derivative of cos of x is negative sin x. The third derivative of negative sin x is negative cos x. The fourth derivative of negative cos x is sin x. And this one will be the same when you find the fifth derivative, when you find the sixth derivative, when you find the seventh derivative, and when you find the eighth derivative. The derivative of 0 is 0, but now the first derivative of 0 is 1. The second derivative of 0 is 0. The third derivative of 0 is negative 1. Yeah? And the fourth derivative of 0 is 0. This one will be the same as when you find the fifth derivative, when you find the sixth, when you find the seventh, and when you find the eighth. This one simply implies that the derivative of cos x is negative sin x. When you derive negative sin x again, you get negative cos x. When you derive negative cos x, you get sin x. The same way that the first derivative of 0, of course, is 1, right? And then negative sin of 0, of x of 0 is 0. Negative cos of 0 is negative 1. And sin of 0 is still 0. This one implies the same to fifth derivative, sixth, seventh, and eighth derivative. So, in Maclaurin series, the only difference between Maclaurin series and Turner series is that in Maclaurin series here, C tends to 0. C is 0. That's why you've not been told to center anything in that example there. So you'll have f into x to be equal to f of 0 plus f prime of 0 into x minus 0. Now here we don't do c because here we don't have c, raised to power 1 plus f second derivative of 0 into x minus 0 squared over 2 factorial plus third derivative now of 0 into x minus 0 raised to power 3 over 3 factorial, and this one continues up to infinity. f of x will be equal to f of x will be equal to 0. F of 0 is 0, according to f of 0 here is 0. The derivative of 0 here is 1, so we'll have plus 1. X minus 0 is x, raised to power 1 is still x, so 1 times x plus second derivative of 0 was 0 here. Now 0 times x squared will still be 0, but all of this 0 affect everything here, so you will still have 0 plus that derivative of 0 was negative 1. So x minus 0 is x raised to the power 3. So you'll have negative x raised to the power 3 over the 3 factorial. Plus, when you continue with the 5, 6, and 7, and then 8, you'll have 0 in 4. Then 1 times x cubed or 5 factorial in the fifth one, then 0 again in the sixth one, then minus 1 times x raised to the power 7 over 7 factorial in the seventh derivative. Now, f of x, we are told that f of x is sin of x. Now, sin of x, you replace sin of x will be equal to, you don't include 0 here now. Now, this one is x. You can write x raised to the power 1 raised to the power 1 over 1 factorial. 1 factorial is still 1. Minus now, here is 0, don't include, minus x raised to the power 3 over 3 factorial, yeah, plus x raised to the power 5 over 5 factorial minus x raised to the power 7 over 7 factorial. Now, from here, we are now going to introduce what we call summative notation. Now, we'll have sin x will be equal to, when n is 0 and to infinity, we'll have x raised to a power 2n plus 1, right, over 2n plus 1 over the 2n plus 1 again factorial times negative 1 raised to a power n. How did we come? This one is your Maclaurin series for the function below. How did we know about this? Now, remember, if we have 1, 3, 5, 7, 9, and maybe even 11. When you look at when n is 0, you have to find 1. When n is 1, you have to find 3. When n is 2, you have to find 5. When n is 3, you have to find 7. When n is 4, you have to find 9. And when n is 5, you have to find 11. What does this bring into your mind? This one simply imply the arithmetic sequence. And if it implies the arithmetic sequence, then you know that a n is given by a plus n minus 1 into d. In this case, when we have a is 3 now, plus n minus 1. The common difference here is 2 times 2. Here we'll have an will be 3 plus 2n minus 2. So an will be 2n plus 1. Now this is where we've gotten 2n plus 1. This is where we've gotten 2n plus 1 here. So the 2n plus 1 is here, right? And where we've gotten negative 1 raised to a power n. Remember, when n is 0, when it's positive, right? The another thing you have to look at here is the alternating signs. We have positive, negative, positive, negative, positive, negative. The alternating signs. Now n is 0 when it's positive, and negative 1 is the power n when n is 0. This one also brings you positive. That's why we use negative 1 raised to the power n. This one. Now we come to our solution then. We've come to our solution of finding the function fx to be equal to sin x by the Maclaurin series. If you like this video, don't forget to subscribe. See you in my next video.